What's poppin', dogs? Mr. Allen here with 3 different tables of values in this one. We want to determine if these functions here are either linear, quadratic, or exponential based on these values. And when you're dealing with tables, there's certain strategies you can use to determine this pretty quickly. All right, so if I look at all my inputs here, they're all changing by 1, right? So it's consistent there from -2, -1, 0, 1, 2. All going up by 1. Cool. What I want to look at next are my y values, my outputs, my f of x, right? When I input -2, I get 10. When I input -1, I get 5, so on and so forth. What's happening from one to the next? I go up, or sorry, down, down by 5, down by 5, down by 5, down by 5. It's going the same every single time. If it's changing the exact same every single time, this is linear. There we go. That's it. First one done. First one done. Lovely. All right, next one. 0, 1, 2, 3, 4. Good. Then I got up by 1. Then I got up by 2. Then by 4. Then by 8. Oh my goodness. If it's doubling each time by what it's going up by, that's exponential. Exponential. I'm not asking you to actually write these equations, these expressions, whatever, functions, I guess, right, for these. I'm not going to ask you to write the functions here in this one. Just identifying what it is, okay? Linear is not too bad to write, but the exponential gets kind of tricky at times, and you may not be into that yet. So we're just keeping it simple here with this one, all right? Last one here. We have 6, 7, 8, 9, 10. Yay! They're all by 1. Then I got to look at my y values, or my h of x values. They're changing differently. Okay, so we got, let's see here, plus 1 on that one. -2 to 1, that's going to be plus 3. Then I got plus 5 and plus 7. Well, the last one was doubling each time. That was pretty clear. 1 to 2 to 4 to 8, right? That was doubling each time. That's not happening here. But from 1 to 3, that goes up by 2, right? So plus 2. 3 to 5, that goes up by 2. 5 to 7, that goes up by 2. So my second set of differences, if you will, are consistent, right? That is indicative of quadratic. I hope that was the right big vocabulary word to use there. Indicative of. I think it's right. We'll find out. Someone will roast me in the comments if not. That'd be cool, though, if I got some comments. I'd love comments on the video. All right. Let me know in the comments if indicative is the word that I wanted to use there. Second difference is being the same. In this case, 2, 2, 2 is indicative of a quadratic function. I really just sold in. I'm going all in on using the word indicative here. I really hope I'm right in this one. All right, there we go. We got linear, same difference each time. In this case, it was going down by 5. If it was going up by the same number, still linear. Exponential, those differences are doubling in this case. They could also be tripling. They could be quadrupling, right? And then quadratic, the second differences are the same. All right, there we go. That's all we need for this one. That's it. Linear, exponential, quadratic. We answered the question based on these tables. That's dope. That's awesome. You guys are awesome. And make sure to like, subscribe, and all the YouTube things after you watch this video. If you liked it. I bet you loved it. I bet you loved it. See you dogs later.